Hello.
You know that things. If I do one tree,
Good afternoon, everyone. Why do we have many people by this time?
sir,
Why do we have many people by this time? Normally, we beg people to come. Why- We have so many people joining. Is this the first time we are joining?
I think some people this is the first time they are joining.
Oh,
Yes. Maybe those that were just added.
all right. Yeah, Hey. Yeah, but that's fine. Maybe they can just watch what's going on first. Because at this stage it's like just coming into a horror movie. Okay, we'll see what we can do.
Okay.
So probably, normally for the new ones, you know how we try to do it for the first set, that maybe between 12 and 1, just to kind of do like a brush up with them, right? Then from 1 o'clock, continue our normal session. I think
Yes,
that
sir.
I think that we can do from next week to help them.
Okay, sir.
Because coming here for the first time to look at what we are doing, wonder what am I doing in this place? So we don't scare you guys. Yes, first class, you're welcome. Welcome. While you are trying to get your other people, let me just be talking with the new ones so that they know where we are so far. Is that okay?
Okay, sir.
All
Yes,
right.
sir.
Okay. Then let us know when we can start. All right, guys. So welcome to the data analytics club. So here, basically, in the data analytics club, it means that one, you have interest, right, in data analytics. Not just about your school work, it's more about having more practical experience, right? Learning a lot of skill sets that you require. Because most of these tools that we are going to teach in class, most time we limit it to either Excel and Power BI. Okay? For the industry, it goes beyond that, right? So you need to be exposed to as many tools as you want. Okay. So apart from your competency in tools, you also need to also learn how to work on projects. Okay. And not just what we are doing here, also even your own personal projects. Also try to build your own personal projects. Okay? And whenever you have any questions relating to analytics, you just put it on the book. Okay, just to engage. All right. So normally, if you remember how we start our process, right? That most times it starts with a problem in the organization, right? And based on this problem, we need to raise certain what questions, right? And based on these questions, we now have what our objective. So the objective of your analysis now becomes to what? Provide answers to this question, which we now refer to as what your insights, which gives you a better understanding of what the problem is. Okay. And to answer these questions, what do you require? You need what? Data. Okay. And where is this data stored? It's usually stored in your database. So what's your job as an analyst? Your job is to do what? Extract that data. Your job is to do what? Analyze that data. And when we say analyze data, it implies you are what? Cleaning. So cleaning and transformation. Right? And your last thing is to build what? A report. Okay. So the tool so far we have looked at, especially when you are extracting your data, Which tool do we use to extract data? Which tool do we use to extract
SQL.
data? That's the
SQL.
SQL, isn't it? Your SQL. Okay. In cleaning and transforming or analyzing your data, we have looked at what? Excel. Okay. Currently, now we are looking at what? Python. Okay. So after Python, I think after Python, the next tool we are going into is now R. All right. So these are tools you can use in what? Analyzing your what? Data. Okay. Then in building your reports, the tool you now use is Power BI and probably Tableau. However, you can also do your reports using what? Excel and even Python. But these are core reporting to BI tools. Okay. So they are mostly for what? Visualization. So means as analysts, we will need at least 3 skills. 1, SQL. 2, but Excel should be number 1 you learn, right? You learn Excel first, followed by what? SQL and probably Power BI 3. All right. Then when you are finished looking for trouble, then you can now come to what? Python. Those are the at least 4 skills you will require. Now, whichever one you learn, whether it's Python or R, they are still almost similar, but preferably we learn Python first, because currently now you see with the introduction of integration of Python in Excel, we now see that this tool is a skill that almost every organization will now need globally. Okay, so you can stick with that. And because your Excel is Microsoft, right? So Power BI is still another tool again. However, it depends on some countries, like in the US, you may see them tilt towards Tableau. But again, it depends on the organization. But whichever one you learn, it really doesn't matter. It's still the same process you do. Okay. So this is just where we are. Okay. Now, beyond, so this is basically what you are going to do as analysts. Reporting. So building what? Your report. Now we have gone beyond this report now, right? We have gone beyond this report. Because if you remember, in data analytics, there are 4 levels to data analytics. What are the 4 levels in data analytics? What are the 4 types of data analytics? What are the 4 types of data analytics?
Descriptive.
Yes.
Ordinal.
Well, descriptive. Ordinal is what? When you talk about your data types. In fact, those are your measurement of variables. That's when we talk about your nominal, your ordinal, your interval, and ratio. That's different. Okay. But when you are talking about data analytics, there are usually 4 types of analytics that you do. The first one is what? Looking at what has, which is what? Descriptive. The next question is why has it happened? Which is what? Diagnostic. What's the next one? What's the next one? What will likely happen?
I thought predictive.
That's predictive analytics. Predictive analytics. Then what should we do to make it happen? What should we do to make it happen?
Prescriptive.
That's called prescriptive. Can you see that? So all we have done so far, descriptive and diagnostic, this is what the core analyst will do to stop in this reporting. Now we are going a step further now, going into what? Predictive analytics, right? Now this is where we now differentiate between a data analyst and a data scientist. So up to all this point, data scientists can also do it, but it goes beyond it, right? So it also goes into what? Predicting. So at this point, we now have to now build what? Machine learning models. So this is where we are currently now. Is that okay? So this is where we are currently. So we are now learning how to what? Build machine learning models. We have looked at several algorithms, right? And if you remember, we said that your machine learning model or machine learning generally simply means what? When we talk about machine learning, what does it mean? Machine learning. So we're talking about machine learning. What do we mean by machine learning? Machine learning. Yes. Machine learning. Machine learning. So what do you mean by machine learning?
I think it's the use of computer
Mm-hmm.
or artificial intelligence to predict results and outcome.
Okay, so basically, yeah, part of that, yes. Any other one? Machine learning.
I think we can say it involves using machine to study pattern driven by data we have.
Yeah. Yes. So machine
I
learning.
think,
Yeah, go ahead.
okay, so I think it's also a way whereby data imitates the way human reasons.
Yes. Because see, another thing we need to also understand that most times what we are trying to do is to make prediction. But how we make prediction is based on what the patterns, right? There are some certain patterns that are not just clear to the human eye, right? Because how we as human learn, we learn through experience. So they tell you experience is the best teacher. That's how we learn. But machines are more likely to learn faster and more accurately. Okay, but you know, again, it's garbage in, garbage out. So when you talk about machine learning, it's just simply how the machine what learns by recognizing what patterns. Okay, so when you say machine learning, so when you say the machine simply means the computer. Learning simply means what? About the pattern recognition or finding patterns in the data. Okay, but how does it find patterns in the data? It finds pattern in the data using what they call an algorithm, right? And we talked about algorithm, right? So what's an algorithm? When you hear an algorithm, so machine learning is about what? How the computer finds pattern in what? The data using what? Algorithms. So what are algorithms? So when you hear algorithms, what's an algorithm? What is an algorithm?
A step-by-step process of
Step
doing
by
things.
step, you know, step by step. I think last week we gave examples. For example, if you want to make tea, how do you make tea? If you want to make tea, how do you make tea?
You bring out a teacup and pour in hot water, put
Yeah,
a
but
tea bag.
the first step is to do what? What's the first step?
You bring out a
Boil the
teacup.
water.
Boil the water, right? The water must be there now. So you
Yes,
boil
sir.
the water here. After you boil the water, what's the next step?
You put the tea bag
So for you, you may like the tea bag to put it first. Some people would prefer to pour the water first. You know? So it all depends on your own way you like it. All right. So you boil the water, you pour it in a cup, you put the tea bag. Some may add sugar, some may add honey, some may add what again? Do they add milk? Isn't it? Then you
Yes, sir.
That is a step. Is it? So that what you have done there is an algorithm. So what we have described there is what an algorithm, okay, is the step that we are taking, right? So that's why in machine learning, the first thing we need is what? Data. So that is why for a company to say, oh, we have a data culture or want to be AI driven or AI ready, it means everybody must understand that what all the data we have must be put in a form ready for what? Analysis. Because that's what the system is going to be feeding on the data, right? You'll be feeding on the data. So you must always what? Keep that data ready. So that's why the first thing we need is what? Data. And we must have a system of what? Collecting what? This data and putting it somewhere, okay? That's why in most organizations, you now have people specifically charged with what? Keeping that data. Before, they will call them the database administrator. Now, what do they call them? Those guys who are in charge of the data now. What do they call them now?
Data analyst.
Hey, data analyst. No, data analyst is far from it. Data analyst is far from it. Data analyst is just to extract that data. And remember, I showed you the process. Data analyst's job is to extract that data and use. But whose role is it to keep that data? To put it in a way that is ready for you guys to use, as analysts to use.
Data scientists.
Data scientists, not really. Data scientists maybe also do that. He may do that, but that's not his major task.
Engineers.
Data engineer, yes, they are called data engineers. Sometimes they call them data architects. But data engineer, that's actually the people in charge of that. So they pull the data from the different sources, whether it's online from the database, and now push it to a warehouse. You know what a warehouse is? You know a warehouse?
Database.
Yes, but I'm talking warehouse general. What is a warehouse? What is a warehouse?
The large storage space.
A storage space for keeping what?
Data.
I'm not even talking about data yet. I'm just talking general.
Could be anything. Could be
Or
anything.
keeping
Personal
information.
properties or
Anything.
To keep materials, maybe materials, supplies from different sources,
Yes.
That is the same way. So by the time they pull this data from these different sources and push it somewhere, they call that data warehouse. Do you see that? A data warehouse. And that data warehouse can be a database. Okay? Which you, as the data analyst or data scientist, can now go in there, pick whatever, extract the data you need, clean and transform it. Although they try and put it in the usable form, but doesn't always mean that it's ready for analysis. Okay? Then you now go there, extract the data, clean it, transform it, and do your report. So that's where you as analyst will stop. So you see, before you work as an analyst, you need somebody else to keep that data for you, to put the data for you ready. If not, that means you have to do everybody's job. You sort for the data, you clean the data, you transform the data, you analyze the data, you report the data. Okay? So for you to do that, it means you need what? Data ready, right? So that's why in machine learning, there are basically 3 steps. One, we need the data, right? The next step, we use the algorithm to find patterns in that data. It is based on that pattern we have seen that we now use to predict. Can you see that? That is what machine learning is about. Okay. So whose role is it for the machine learning to build machine learning models now? Whose role is it for machine learning models? To be building
Data scientists.
Data scientists. Do you see that? So that's why he goes a bit more advanced than the data analyst. Some data analysts can actually do it, right? But it's not their core skill. So that's why for data scientists, you must also be good in your maths, good in your statistics, right? And also good in research. All right? Must also be good in what? Research. So when they have found the patterns, it's just not enough to find the pattern. You also need to what? Do what? Deploy it. So that's where it comes deployment. So those machine learning models they are now deploying, the data scientists can do it, but they now have another specific group that does that. Who they call who? Machine learning engineers. So can you see from one role, you see how you can now go into different aspects of it. Like for example, those who like building reports, who are very good in building reports, right? In fact, they even specialize, they have another role again, they call them data visualization engineers. So their own job is just for visualization. Okay. So you see, you may not have a core background in tech, right? But gradually through data analysis, you can now see how you can now work, and they can even call you an engineer, but not the engineer that is going to build roads and build houses. So, but they will still call you what, an engineer. Okay. I hope that is clear.
Yes,
Okay.
it's clear.
Good. So that's where we are. So machine learning is just a subset of what? Artificial intelligence. Okay. Because remember, when you say artificial intelligence, you are trying to do the same thing as humans are doing, but in an automated way. Okay. Which means you must first of all deal with what? Understand algorithms, know how to build what? Models. Okay. And it's based on those algorithms, we now look at the patterns to understand the factors that are driving that particular variable or target. Then based on that, we can now what predict going forward. Okay. So that's what we have looked at so far. And if we remember that in our model, we said machine learning models can be broken into two parts. What are they? What are the two parts?
Test and train.
Supervised.
Structured,
We said machine learning models can be broken into two. What are they?
Supervised and non
Supervised and
supervised.
unsupervised.
Supervised machine learning and what?
Unsupervised.
Unsupervised machine learning. Right? I would say the difference is that unsupervised, they have labels. They are well labeled. So look at it, what we are saying, that if you are building a model, y is a function of x, and we say y stands for what? What does y represent?
Dependent variable.
Dependent variable.
Which is
your
called,
target,
Which is the
called
target?
Target.
target,
Target, exactly. Yx is called what?
Future.
Measure.
Future.
future,
Dependent variable, or what we call what? The features. You know? So for example, we are trying to understand, why do people buy a product? You know, why do people buy a product? Okay, why do people buy? So it means here, what will be my target variable now? Why do people buy our product? What will be our target variable?
Sales.
Sales, you know?
Yes.
Sales, okay, so sales can be. So that's why when you have mentioned it, you must think a way about how to what measure. So measurement is key. So one skill we need to learn is how to measure. Okay. And remember, there are different ways of measurement depending on the kind of data. Okay. Your measure can be what? Nominal. Your measure can be what? Ordinal.
Ordinal.
It can be all these other ones. We can just take them as a scale, right? Ratios. We can just call them scale, whether it's ratio or interval. Okay. So your nominal is usually for what? Qualitative data.
Qualitative data.
Why this is for what?
Quantitative.
Quantitative.
Okay. We gave example of nominal. What's an example of a nominal data? Example
gender,
of,
gender,
gender, is it not? Gender. Which other example of a nominal data?
religion,
Religion. Religion, you know, good. What about ordinal?
The Likert scale.
Likert scale, right? Same. The reconductant, Likert scale. What does Likert scale mean? For example, you have
Good.
what extent do you like our product? Or they say, do you enjoy our services? We have good services. Strongly agree, agree, undecided, disagree, strongly disagree. Can you see that? How did you enjoy our service? Excellent, good, very good, right? Good, average, you know, bad, very bad. Can you see that? This is the Likert scale. So there's an order to it. So it can be like maybe 6, 5, 4, 3, 2, 1. Can you see that? So there's an order. It means 6 is better than 5, 5 is better than 4, 4 is better than 3, 3 is better than 2, is better than 1. But for gender, when we have male and female, if I say 1, 2, does it mean that 2 is greater than 1? Is 2 greater than 1?
No.
No.
So we are just using the numbers just to assign them.
Yes.
Do you get that? Because
Yes.
you cannot just use the text on its own to do the analysis. You have to convert them to what numbers. Do you see that? So that's why you must what measure. For your scaling, it's either it can be interval or it can be ratio. So they are usually what quantitative what data. All right. Which means the way you measure your data will now determine the kind of what algorithm you are going to apply on your model. Okay. So the question we ask, what was that question we're asking about sale? Why do people buy? Is it not? Or what makes our customers purchase from us? Okay. So we are interested in whether they are going to make purchase or not. Is it not? So either they are going to make purchase or not. So if they make purchase, yes. If they make purchase, no. Is it not? So here we can assign, because we are interested in purchase, we assign 1 for purchase, 0 for what? No what? Purchase. You see, it can only take 2 possible outcomes. What do we call this? When it has only 2 possible outcomes, what do we call it?
Binary.
It's called binary. Is it not? Binary. And because of this, it now falls within what they call a probability. Because remember, probability lies between what? 0 and what? 1. Can you see that? So when it has only 2 possible outcomes, it is now the kind of algorithm we use is called binary what? It's called binary what? Logistic regression. It's called what? Binary logistic. Okay? So it is the measure that you use that will determine it. I hope this is clear.
Sorry,
Yes,
my
sir.
name is bad. I didn't get the binary explanation.
Okay, sorry, you didn't get binary. So let's break it again. Let's take it again. Let's assume you are what's your background or what's your profession? Let's look for an example for you.
Physical security.
Yeah, what?
Physical security.
You said digital security?
Yes.
Digital security. Okay.
Yeah.
So when you say digital security, so let's talk about maybe something like fraud. Would that be part of it?
Not really, like access control.
Okay, like access control. Okay, let's assume it was fraud, right? So let's say what factors will drive fraud, or why do you commit fraud? Or what factors should we look out for that are fraudulent activities? You know? So it means my target there is going to be likely going to be fraud, isn't it? That is my why.
Yes.
You get that? So it's either the event is fraud or not fraud. So if it's fraud, that is yes, or there fraud, yes or no. So we assign 1 because 1 simply means what we're interested in. If you're interested in no fraud, then this will be our 1. So that one represents what you are interested in. So
I
since you are
see your
interested in
screen.
fraudulent activities, so it will assign what? 1. Can you see that?
I can't see your screen. Or is it mine?
Check your network.
Okay.
Can you guys see my screen?
Yes, sir. We can see your
Yes,
screen,
sir.
sir.
We can
I
see.
can see. I
Yes.
can see. So I guess it's network.
Okay, good. So we are looking at fraud, is it not? So we are saying, was there fraud committed in it? Yes. Then we assign 1 because that's what we're interested in. So anyone you see 1 means your interest.
Okay.
Why no means 0. You are not interested in it. We are now looking at what factors can drive fraud in organization. So what factors can drive fraud in an organization that they will commit fraud? Because based on this fraudulent list that we can now know what security things mechanism we can now put in place, is not to deter or what detect what the fraud. So what factors will drive fraud now? What factors will drive fraud?
Poverty.
Poverty. Now you see anything we mentioned, poverty. How do you measure poverty now? How do you measure poverty? If you say poverty now, how do you measure poverty?
If you're not earning enough to take care of your direct needs, you
Say
must
what?
earn more. You're not making enough money to take care of your daily
So that
needs.
means income
Poor
level,
salary.
right?
Poor salary.
That's income level, right? Or salary level. So maybe it can be position.
Yes,
Your
position.
level in the organization, which can directly related to what? Your income level. Right? Good. Because remember, anything we mention, we must have a way of measuring it. Okay? Either the data is qualitative or what quantitative, but we must have a way of what measuring it. Okay, so income level, what again? Maybe position, right? Position. So either the person can be, how can we categorize position in the organization? How can we categorize positions in the organization?
Senior management.
Senior management, good. So senior
High or low?
Aha. So all depends again whether you want to use nominal or you want to use what? Ordinal. In this case, which one will it be? What kind of measurement will it be for position? Nominal or ordinal?
Ordinal.
Nominal.
Ordinal.
Because there's a level to it, is it not? And what you expect,
Yeah.
who will commit more fraud? Lower level or higher level staff?
Lower level staff.
Of lower level, is it not?
Higher level.
Higher level. So again, it depends, right? It depends. It depends. Okay. Good. So we have senior, so we can say senior management, middle management, and maybe we say lower management if we decide to break it into 3 like this. So it can be something like this. So how do you want to order it? Which one will have more weight? Is it 1, 2, 3 or 3, 2, 1? Which one do you prefer?
3, 2, 1.
2-1.
So 3, 2, 1 like this. 3,
Yes.
2,
2,
1. So you
1.
know how you're interpreting this now? It means that senior management have more weight than middle management. Middle management have more weight than what? Lower management. Is that not it? That's by measure. Can you see that? Good. So that's
Yes.
that's position. Oh yeah, what again? What other factor can drive it?
Greed.
Yeah?
Can greed drive it?
Okay, greed. So if you say greed, how do you measure greed?
How do we measure?
I don't know. That's what I'm asking.
No, but that's where the work comes in, right? So there are 2 ways you can select the variables. One from theory. What does theory say? So you have to go back and research. You know, what are those factors? What are those determinants of fraud? Or it can be from observation. Now, from observation, you are seeing greed, is it not? Now, the question now is that, so when you say greed, first question should come to your mind, how do I measure greed? And you know what measurement means? It means I must think about a way I will get data to measure it. So how does it go? It goes from variable. So variable can be a very conceptual, it's just very abstract. So we say the variable is grid. Now, how do we measure grids? So how do you think you measure grids? How can grid be measured?
Qualitative.
Yes, it's qualitative. I agree that it's qualitative, but how can we measure it now? It may not exist now, but your job now is now to think about how to measure grids.
Is it like the cost of grade or what?
Yeah?
Okay, so can we use level of satisfaction?
Level of what?
Satisfaction to
Level of satisfaction. Okay, we are now getting the level of satisfaction, right? Level of satisfaction now. Now, when you say level of satisfaction now, so what do we mean by level of satisfaction?
In terms of compensation.
Another way
So compensation.
we can look at
Compensation
contentment.
can be another one. So it means that, so it means greed to us means that you are highly compensated, but yet
Mm-hmm. You are not contented.
you are not contented with it. So that can be a measure of what greed, isn't it? Now, can you see how you have what? Brainstorm to come about a measure. Then once you have got the measure, the next is now how to get what? The data. Can you see how it goes? From variable to measure to data. That is how you must always be thinking about almost everything we are working as analysts. Okay? So that will be a measure. So all we have done here is what they refer to as what? Feature what? It's called what? Feature selection. Because we are selecting our features. It's called feature selection. So it is based on this data we have collected and this one that we now apply what? An algorithm. We now what? Apply what? An algorithm on it. What will the algorithm help us do? What does the algorithm, what does it help us do? What does the algorithm help us do?
To recognize patterns.
To recognize the pattern based on what? Your model. Can you see that? It's based on that pattern in your model that you will now use that model to do what? What do you use that model to now do? Prediction. Can you see that? It is based on this prediction now that you now understand the pattern, then you now what? Have to now deploy or come up with what? Strategies. I hope it makes sense.
Yeah, it makes sense.
Yeah.
Yeah, good. All right. So let's go back to that our analysis now. So we said that machine learning can be broken into two parts. What are the two parts? What are the two parts?
Supervised and non-unsupervised.
What? Unsupervised machine
Learning.
However, some will break this one further into what they call reinforcement learning, or what sometimes we refer to as deep learning. What they call deep learning, right?
Sorry, is that under machine learning or under the unsupervised?
Under machine learning. Some will argue that we can group them into two, so they can take all this one under unsupervised. Some will decide to separate them, that no, they're supervised, unsupervised, and there's also deep learning. Okay. Now, under this, but let me just explain the one after the other quickly. Now, under supervised machine learning, it simply means you have what they call labels. You remember that model we built? Y as a function of X. What causes people to commit fraud? Is it not? So fraud here, we said if they committed fraud, yes. Did they commit fraud? No. Is it not? So you see, there's a label. Can you see that? They have labeled it, yes, fraud 1, no fraud 0. Or just even think about banks. If they want to give loans, right? Loans. There are certain kind. What's the likelihood that this person will not default? Can you see that? So whether the person will default or not default, is not. So because we're interested in default, so we assign 1 there, is not. Otherwise, 0. So these are our what? Target variable, default. What are the factors that will drive whether a customer will default or not? What are those factors we look out for?
His previous history of
Previous history, right? His previous
Yeah.
history. So can you get data for that? Previous history. Previous history. Can you get data for that? So when
yes, you can if he has been with you or
so if he has been with you, so his past record, not. So that means you must have record about him. Right? But remember, this model you are trying to build is based on your current what? Database, is it not? So things you can have customer information, is it not? Like you are looking at what? Their age, is it not? You are looking at what again? Marital status, is it not? Marital status. What again are you looking at? Level of education. What again are you looking
socioeconomic class,
at?
socioeconomic class.
Economic class, is not the economic class. What again? Is maybe
income.
right? Income level, maybe
Number of dependents,
number of dependents, beautiful. Number of dependents, beautiful. What again? Number of dependents, what again?
Properties and assets, I guess.
Yes, assets, whether it has assets, right? Like collateral or not, isn't it? Good. Now, based on this, what have we done? We have looked at all the data that we have, is it not? Going forward. It is based on this, we can now use to predict, right? We'll now come up with a model. So this is the model we have come up with. Based on this model, what do? We are going to apply an algorithm. And this algorithm now depends whether it's a supervised, unsupervised, or a reinforcement learning model. Okay, so we have different algorithms under each of them. So by the time we apply the algorithm, it will now bring out what? Patterns for us. It is based on these patterns, we can now use to what? Predict going forward. You know, we can now do some what? Prediction. Once we rely on it, then we now what? Deploy. So in that deployment, you want to enable us to take quick what? Decisions. But remember, at the end of the day, even if the machine helps you take decision quickly, it's still left to you as the manager. It's not to still check on it on a case basis. It will help you take it, but you still have to look at it on a case by case basis. All right. So which means if it has built up a model, a pattern for you, and we now say, okay, this is now the model we are going to use. So going forward, when a new customer now comes in, what do you now do? When a new customer now comes in, what now happens? When a new customer now comes in and says he wants to
apply the model.
Thank you. Is that model? Isn't it that you now come and check and say, oh, how old are you? Oh, you say it's 20. Are you married? No, single. Isn't it? Are you employed? No. Do you have any assets? No. Do you have any income level? No. Isn't it? Based on the pattern it has seen in the past, what will likely happen? Based on the pattern it has seen,
It will classify.
it will classify as likely high likelihood of what? Default, is not. So even if we say
Yes.
1 to default, now what is the probability that he's going to what? Default? So whenever it's greater than maybe 50%, we say it is what? High, is not. When it is lower than 50%, we say it is what? Low. So the high can quantify it, whether it is high, very high, you get moderate or whatever. Then you now also take decisions. Can you see that? So it's now going to do what? The prediction for you. So that's exactly what we are trying to learn here in machine learning, okay? So we say under supervised, they have what? Labels. Can you see labels? What we have done here is called labeling. It's called labeling. Okay, so we have labeled it fraud, not fraud. That's label. The same thing with your child, right? You tell him, this is good, this is bad, this is good, this is, so you are supervising him what he should do. This is, so you are labeled good, bad. Okay, that's supervised. Unsupervised means what? Unsupervised means what? No label. For example, the child, you don't even tell your child what to do, whether it's good or bad. Based on what he's doing, based on the effect, his experience, he will now know what is good and bad for him. For example, there's sweets there on the table. There's a lemon on the table. Because lemon is yellow, maybe the sweet looks black, is in a black cover, it doesn't look so attractive. But the lemon that looks yellow is very attractive, isn't it? You will go and take it and put in the mouth. Isn't it? So when the child takes the lemon and the lime and put in the mouth, what will happen? When the child puts the lime in the mouth, what does it do?
It's soft, so they would remove
Let's
it.
squeeze his face, isn't it? And throw it away, isn't it? At that
Yes.
point, he has learned, isn't it? He has learned, isn't it, on his own, that anytime I see anything that's yellow like this, I will never put in my mouth. So he has learned on his own. Can you see that? But when he now sees sweet, then he now tries it and puts it in his mouth and say, ah, this is very nice. You know? So when he sees sweet now, he has learned. So that's what they call unsupervised. Okay? Now the difference here is that this one, there is data. There is data. Here, there is data. But in this one, there may be data, but not so much. For example, like your Tesla car, it will be learning from the environment. It will learn with past data first, but it will now collect new data. Based on the new data, apply to the model it already knows, and use that to make decisions. So that's why, like a Tesla car, it can be scanning the areas. Okay, it can see the road, it can see people, it knows the path it should take. But because where it has already been training, maybe like in the US, where the roads are so good, people drive like normal human beings. You now bring it to a place like Lagos, and it has never seen this our motorway or conductor with big potholes, isn't it? At that point, it's now picking data, live data, isn't it? Reading it through the model and taking decisions, whether I should continue, stop, avoid, divert, and now keep going. But it will be learning on its own. That's why they call it reinforcement learning. Okay, reinforcement learning. So I hope that is clear.
Yes, sir.
Good. So for that, our supervised machine learning, there are usually two parts. There are usually two. There's what they call regression, linear regression. And there's the one that we call what? Classification. So the one we have done so far, we have done linear regression, right? Yes. Where we have y as a function of what? X. Okay. Y as a function of x. Now, where is our y? Is a what? Continuous data. You know it says continuous. It's quantitative, is not. It's quantitative. For example, things like what? Price. Price. Is not. Price of a house. Exchange rates. Oil price. Right? So the moment your target variable is what? Quantitative, the algorithm we apply is what? Linear regression algorithm. Do we get that now? Is that clear?
Can you just take that again? It's a bit.
We are saying that where your target variable is quantitative, you know, remember quantitative data can either be discrete or continuous. Can you see that? So as long as it is what? Quantitative. Example is what? Price. Another example of quantitative data is what? Another example of quantitative data is what?
Sales.
Sales. Beautiful. Another example? volume, right? Exchange rates, oil price, all these are what? Quantitative. So anytime our objective is to predict any of these quantitative data, the appropriate algorithm is called what? Linear regression. I hope that is clear. Do we get
Yes.
Yeah, okay, sir, that is clear. But ab initio, what will you define as regression before you now classify it as linear and non-linear?
Okay, what is regression? Okay. So regression normally, although because we're not going theoretical, it's more practical than theoretical. So regression simply does three things for you, right? So regression, first of all, understand regression as what? Pattern recognition. Pattern recognition. Anything you see about AI, machine learning, at the back end of it is what? Regression. Because regression is about what? Pattern recognition. It's going, when you say you're progressing means what? When you're progressing, it means what? Progressing means what?
You're moving forward, you're going forward.
Going forward, it's not. Regression means what?
Backwards.
Regressing.
It's going back.
It's going back, is not. So regression simply means looking at your past data, is not. Understanding the pattern. Based on that pattern, we use it to what? Make predictions going forward. You see that? So that means regression does three things for you. One, it looks at what? Your relationship. It looks at the relationship. Two, it looks at what? The cause and effects. It looks at what? The cause and what? Effects. Right? And the last one, it helps to what? Do prediction or what? Forecast. So regression in simple terms simply means what? Pattern recognition. But the kind of regression you are going to apply now depends on the kind of what? Problem you are facing. So where our target is quantitative in nature, whether it is price, sales, volume, is not, the kind of machine learning algorithm we are going to apply is called linear regression. I hope that is clear.
Yes, sir.
Okay, good. Great. Now, if this our Y is qualitative, is what? Qualitative in nature, we can no longer apply what? Linear regression. Why is that so? Because one assumption of regression is that this your value of Y is random. You know what something is when they say something a random variable? You know when they say variable is random? When you say variable is random, what does that mean?
Equal chance of occurrence.
Yes, and it can take any value. It can take any value. Is it not? It can take what? Any value. But you see, in that case of fraud or default, it can only take value between 0 and what? 1. Can you see that? It can only take values between 0 and what? 1, which makes it what? Limited. And because of that, it can no longer apply the word linear regression. So what do we now use? Because it has only two possible outcomes, it is called what? Binary, isn't it? So the model we apply is what they call binary logistic regression. Did you understand that? It's called binary logistic regression. I hope this is clear. Is this clear?
Yes, it's clear, sir.
Good. So this is what we are expected to do today. Binary was logistic regression. We did the linear regression last week and last 2 weeks. Okay, we have applied this. So let us see how we can implement this. Okay. Let's see how we can implement it. Now, whenever you see, so how do you know you are going to use a binary logistic regression? How do you know we are going to use binary logistic regression? How do you know?
The target is 0.
Logistic regression.
When the target
How
is
do you
0,
know you are going to use a logistic regression?
If the value is 0 or 1.
Thank you. If it has only two possible
Two
outcomes,
positive
whether it
outcome.
happens or it doesn't happen, fraud, no fraud. Is it not? Which other one? Buy, not buy. Advertise, not advertise. Purchase, not purchase. As long as you can classify it or code it into two groups, then you can apply logistic regression. Is that clear? You can apply logistic regression. And that is why in practice, most of the problem we have, machine learning problem, fall under what? Classification. Most of them will fall under what? Classification. You are trying to what? Classify them. Okay? But not everything goes in that binary form. But you can also do what? They fall under what? Classification. Okay? They fall under what? Classification. I hope that is clear.
Yes, it is.
Good. All right. So let's make progress from there. So what we have seen is that under machine learning models, it can either be what? Supervised machine learning model or unsupervised machine learning model. Okay. Now, under the supervised machine learning model, it can either be what? Linear regression or what? It can be linear regression or what?
Or logistic regression, rather.
Binary logistic regression.
So that's classification. And under your classification, we now have what? Binary logistic what? Regression. You see that? Do we get that? So if, for example, now we want to predict performance score. Performance score, right? Performance score. Which algorithm do we apply? Performance score. Which algorithm do we apply? Performance score.
Linear regression.
Linear regression.
Linear regression.
What about, what if you want to check, will this employee jackpot or not?
That's logistic.
Binary.
Binary.
Because either he leaves or he stays. In HR, what do we call that? What's the technical name for that in HR? Do you have any HR person here?
Attrition.
Attrition is called what? Attrition, is it not? So when we have an attrition problem, what machine learning classification we apply to machine learning algorithm we apply to that? Binary
logistic regression.
Exactly. I hope you understand it now.
Yes, sir.
You understand it. Good. So if we think about the entire process, if we think about the entire process, okay, what we are simply trying to do, one, we are going to what? Get data. Where is my? So one, we will need to what? Get data. Based on that data, what do we do? Most time we need to clean it, is it not? And process the data. Once it's cleaned, we clean and transform that data. Okay. The next thing we are going to do to that data, we are going to what? Split the data. We split it into what? What they call the trained data, and we split it into what they call what? Test data. Do you understand what train and test means? Train simply means, oh, if I have the entire data, this is 100%. I'm going to break it into two. Either I use 80% to train and 20% to test. So that means let the model not see the entire data, just see a part of the data. Based on it, we'll now use to test to now know what extent we are going to rely on it. If we now check the accuracy of the model and we see that, okay, we can rely on this, then we can now go ahead and do what? Deploy. We can now do deployment, but we need to test the accuracy. So the higher the accuracy, the better. Okay, the higher the accuracy, the better. Is that clear? Do we get
Yes.
that?
Yes, sir. You got it.
Get that? Great. So let me quickly try to explain. So we understand the concept now of the logistic regression, right? We understand the concept of the logistic regression. Okay, it simply means where your target variable has only two possible outcomes. Is it not? It has only two possible outcomes. It has only two possible outcomes. Only two possible outcomes. However, in logistic regression, or let's say in classification, one of them is what they call your binary logistic. There's another one you have what they call multi-class regression, multi-class classification. You know what multi-class means? Binary means only 1 and 0. Multi-class means you can have 1, 2, 3, or 1, 2, 3, 4, 5. For example, your multi-class, and you also have ordinal. So 1, 2, 3, 4, 5. What's the difference between ordinal and multi-class having 1 to 5? What's the difference? Multi-class 1 to 5, ordinal 1 to 5, the same category, but what's the difference between
Ordinal is killed.
Yes, that under your multi-class, or what we call multinomial logistic regression, it means that your 1 to 5 has no order. It's just like gender, it's nominal now. It's just like saying choose your religion. 1, 2, 3. I will not say Christian is better than Muslim, or Muslim is better than traditional. It's not. We are just assigning 1, 2, 3 just to number them. So in that case, that's what they call a multinomial logistic regression. But when we say choose your preferred network, Glo 3, MTN 2, Airtel 1, can you see that 3 is greater than 2, 2 is greater than 1, is it not? In that case, there's an order to it. So that's called ordinal logistic regression. I hope that is clear. So it means we talk about logistic regression, but there are 3 types. It can be binary, it can be multinomial logistic regression, or it can be ordinal logistic regression. I hope that is clear.
Sorry, I didn't get the difference between the multi-something regression and ordinal.
Okay, so let's do that. Let's do that again. Let's give example. Remember, when we talk about measurements, right? We talk about measurements. Under measurements, right? We said it can either be nominal or it can be ordinal. You see that? That is why we said that the kind of data you collect will determine the kind of analysis you are going to do. So that's why we must always take note of it. Okay? We gave an example of nominal data. Give an example of nominal data. We gave what? Gender. Is it not? We gave gender. Maybe another one, let's say political parties. Political parties. Can you see that? If we have 5 parties, 1, 2, 3, 4, 5. We have 5 parties. This 5 parties, 1, 2, 3, 4, 5, is just to assign names to them. For example, you can have LP, you can have PDP, you can have what? APC, you can have which one? Which other one?
YPP.
YPP, you can have YPP, you can have AC. You know, we are just using numbers to assign them. So we are not saying that 1 is better than 2, or 2 is better than 1, or 3 is better than they are just names. You know, we are just using numbers to assign the names. So they are called nominal. Is it not? Where I only have 2 possible outcomes. For example, yes, no. 1, 0. Can you see that? Or yes, no, 1, 2. You see that? So whenever we do it in this way, this one means that 1 means we are interested. We're interested in it, you know. Though it is they are both binary, right? But 1 shows you here that this is my interest. But when I do 1 and 2, it shows that I'm not interested. I'm just using 1, 2 to what? Just explain them. So that's why it's called nominal. It's called what? Nominal. But here, specifically, we refer to it as what? A dummy variable. They are called what? Dummy what? Variables. It is nominal, but specifically it's called a what? Dummy variable. Because that's to capture what I'm interested in. But nominal in this case just means 1 for yes, 2 for no. At this point, it doesn't mean that 2 is greater than 1 or 1 is greater than 2. No. But when we come to ordinal, for example, I now say, choose your preferred party. You see, preferred party, preference is key, is it not? So if I have 1, 2, 3, 4, 5, 1 means LP in this case is my most preferred party. 2, PDP. Can you see that? 3, AC. 4, what's that one again? You say what you call YPP, right? Then 5,
Yes.
APC. Can you see that? Now there's an order to it. So this is called ordinal, while this is called what they call it multinomial, or what you call multi-class. Multinomial. So which means in this case, there's no order. But in this case, there's an order. That's the difference. Do you understand it now?
Yes, sir. Thank you.
So anytime you have a situation where it is 1 or 0, the appropriate algorithm is what? Binary logistic regression. Can you see that? Binary logistic what? Regression. But where I have it in this case, where there's an order, no order to it, but there's a multi-layer to it, it is called what? Multinomial logistic regression, or what they call multi-class regression. Why this? Where there's an order to it, it is called what? It is called what? Ordinal logistic regression. And why do you need to understand this? Because there are so many algorithms, so many. That is why there's something they call no free lunch theorem. No free lunch theorem. What does no free lunch theorem? What does it say? No free lunch theorem. What does it say?
No one size fits all.
That there's no one particular model, is not that is the best. So that means you must try based on the ones that they fit, is not those your conditions, and try different what different algorithms, and you now pick what the best. That's all it says. So that's why most time we try to what expose us to as many algorithms as possible. Okay. I hope that is fine. So let me try and share. Did I share that? Did I share any file for that we use for logistic regression? Okay, let me share one. Let me see. Oh,
Sorry, can I ask question before we
yes, sir, go
proceed?
ahead.
Okay, so now, now let's assume we have both quantitative and qualitative data, and you want to see how it affects a particular variable. Now, yet I understand qualitative data should we should use either logistic regression and all that. Well, quantitative data we should use linear regression. Now, in the event we have two data that we should ordinarily use these two different kind of regression on them. So how do we? Is there any other algorithm that we can actually use to do the analysis?
There are so many. There are so many. You know, we are just introducing it, so that way I will not go into into all of them at this stage. But I think by next week we should introduce us to other kinds of algorithms,
Okay.
like
Okay.
nearest neighbor, naive Bayes, naive what do you call it? Bayesian algorithm, naive Bayes algorithm. There are so many, so many. There are so many.
Okay.
So many algorithms. Okay. I
Okay.
will
Thank you.
maybe probably next week we'll try and do as many as we'll do maybe like once you understand the concept here, it's easier to understand and implement it. So maybe,
Okay. Thank you.
all right, so why is this data still open? Don't see it. So there are so many algorithms, Probably I will share maybe something that will show you guys all as many algorithms as possible so that you can see the different kinds. Okay. But I'm just showing the common ones. That's why you see, as data scientist, you see your math and statistics will be a bit more advanced than a data analyst. So this part we are working with now is that of what data science. So what we are dealing with is data science. All right. So when we are dealing with Excel, building reports, dashboard, that's data analytics. But the part we are dealing with now is building models, is it not? And doing predictions. This is now the part of what data scientists. Is that okay?
Yes, very well, sir. Thank you.
Yeah. All right. So can you see that data there? Can we see the data there?
Yes, the advertising.
Yes, sir.
Advertising data, yes. So
Yes.
let's open that data. Let's open that data. And let's look at it.
Please, can you be shared on the WhatsApp group, please?
Okay, please, can somebody share it on the WhatsApp group?
Okay, sir.
Can somebody share on the WhatsApp?
Shared.
Great. Can you guys see my screen? What screen am I sharing now?
Working.
Huh?
Your working board, the last work we did.
Oh. What am I sharing now?
Okay. Jupyter.
Jupyter.
The Python 3, yes.
Good. So let's start. All right, great. So please, for those of you who are joining for the first time or looking at programming for the first time, please, you know when you are watching horror movie, you know how you cover your eyes more. They're using one eye to look at it, you know, whether they have killed the person or they have captured the person. You know how you watch horror movie? Yeah. That's how you watch this one. Until you are ready to watch it with full authority.
Thank you for the disclaimer.
Just use one eye and watching it, you know, so you don't run away.
Thank you for the disclaimer.
You know, last time I said that this is where turbulence is going to be, is it not? You know, when the pilot put on the seatbelt sign and said there's rough air ahead, and this is the rough air now. So hold on, fasten your seatbelt, don't go to the restroom yet, you know, until everything is settled. All right, so what do we do normally, right? So now we first of all need to import the libraries. You know, so what libraries do we use? What libraries do we use?
NumPy, pandas.
Okay, so for now we are using basically two libraries. Import what? Pandas as what? PD, not For those of us hearing panda for the first time, it is not that fluffy animal, but it's the tool that we use. There's another one called what? Import what? NumPy. So we need to import the libraries. So import what? NumPy. Import NumPy as what? NP. Okay. Are we going to do any visualization here? If you have to do visualization, then we have to now import what? The visualization libraries. So this is just like doing Excel inside Python, right? For you to see your Excel tables inside Python, this is what the libraries are going to use. Then if I want to draw my chart, what do I need? I will need what? Import what? Matplotlib dot what? PyPlot as what? PLT. Then there's another one again we usually bring in, import Seaborn as what? SMS. All right, good. So what's the next step? Once you have gotten the library, what's the next step we do? What's our next step?
Bring in the data.
Bring in the data. So I need to get the data. So I've copied the part of the data. So this is the part of my data, right? So what we can do here, I can say df. Df simply means data frame. It means where I'm going to keep the data. You know, now in Excel, you can do all this in Excel. You know, you can run Excel inside Python now, Python inside Excel now, right? So exactly what we are doing here now, you can do this same thing exactly inside Excel. Okay. So what do we now do? We now write what? PD dot what? What's the file? What type of file is it? Is it an Excel file or a CSV file?
CSV.
So CSV, so import CSV file. Then we now read it and what do that. Okay. So if I run it now, df. Did you open your own in Excel? Did you open your file in Excel?
No.
Did you try to open your file in Excel to see what data looks like?
Yes.
Yes.
So can you see
Yes.
that exactly what you have in that your Excel file is what you are seeing here? Can you see that? The only difference is that Excel will show you the entire thing, but this one will just give us the top 5 and bottom 5. Then all this dash means there's something in between them. Okay. So if we look at this data, what do you think it is talking about? If you look at this data, what do you think it's talking about? What do you think it's talking about?
Probably measuring time spent on the internet and data usage across countries and like areas and different age grades.
Right. So imagine someone doing something like you want to do an ad, is it not, on the web page, is it not? You are doing an ad, right, on the web page. Okay. So what you are checking now, did they click on the ad or did they not click on the ad, isn't it? So in this case now, what's our target variable here? What's our target variable here? What's our target? Remember, we said y as a function of x. So what's our target variable here?
Time spent
Clicked on
on
ad.
site.
Clicked on ad or not?
So time spent on site, is not?
Yeah.
Somebody said click on ads. So which of them do we take?
Clicked on ad.
Click on ad, right? So if we check click on ad, what does that mean now? Click on ads. That tells us that what? Click on ad means is what?
It's a binary logistic regression.
It's binary, is not? So that's our target variable, isn't it? So that's our target variable. So it's called click. So one thing with Python is that it is extremely case sensitive, extremely. Click on ads. Okay, so that means I've selected click on ads. What is our, what do you call it now? What's our features? What are our features now? That's our X, you know, so what are our features?
1 or 0? I don't know. Yes or no?
Our features. What is our features?
What are the other columns?
The columns now, is it not?
Yeah, all the columns. Yes.
Columns. So what are the columns you are going to pick now? Which columns are we going to take now?
Age,
You pick
country,
the age,
Okay,
the
age.
area, income,
Is that what? Age, what? Area, income, okay.
country,
Country, okay.
I think gender,
Gender, Gender, what again? Gender, what again?
Add topic. Add topic.
Add topic, right? Add topic. Now, please take note. When you want to do your analysis, remember everything must be in numbers. Do you get? So if, for example, we say countries, we cannot use Tunisia as it is. Right? So it means we have to go and what? Convert them to numbers. Do you understand that? But if there's a particular country of interest, you cannot assign that one as 1, all the others will be 0. Just like, for example, gender. You know, gender, you have male and female, isn't it? In this case, what was their interest here? What was the interest here?
Male.
Just male, if you're male or
male.
Male or female. Because the interest was 1 or 0. But you see, for countries, the countries will be too many there. Okay? So what we are going to do, we are going to carefully just pick our what model. Okay? For now, I'm not going to do any data cleaning or transformation right now. So anyone that has text, we'll leave it for now, right? We'll only pick the one that have what quantitative data. Is that okay? When we come next week, we will now talk about data transformation. What I just want to show us is how the machine learning algorithm works. Okay? So what we are doing at this point, we are now selecting the features, which we call feature selection. So what I need is that I will need some of the words features, up to where? So let me copy these ones. So these are the features I will need. But the ones I cannot work with, there are some I cannot work with. For example, which one can we not work with? I can work with time spent, age, area, daily. Add topic, I cannot work with add topic because it's text in nature, is it not? For you to work with it, what do you now do? You have to now convert it to what? Numbers. Can you see why you have to convert them? Otherwise, you will not be able to see it. City, the same thing. City. Country. Even timestamp. Even timestamp. Even timestamp. Okay. So these are what we call our features. So these are our what features. Can we see that now? This is our what features. X. Can you see it now? So you see we have separated it now. Remember it was y as a function of x, Now we have our x, we now have our what? Y. What's the next step? Now we have our data. What's the next step? What's the next step? Yes, what's the next step?
We clean it.
Normally, we're supposed to clean it. Normally, we're supposed to clean before we do all these things. But at this point, we're assuming it's clean. So there's nothing to clean.
Okay.
So the moment we have our data, the next step is to do what? Once we have the data, the next step is to do what? Break the data into 2, is it not? We're going to break the data into 2. What are they called? The train data and what?
Train test.
Train data and what? Test data. Train data and what? Test what? Data. Can you see that? Train data and test data. Just imagine that you are trying to come up with a new drug. You have collected, you have data in the past. Now, this data in the past simply means that we have tested it on rats, we have tested it on animals, is it not? We have seen the patterns already, how effective it is or not. We have seen all the side effects. Once we have gotten that, the next thing we want to do is that, okay, based on this thing we have learned now, we want to try it on other animals that are close to human beings. You see that we're now doing what? Testing. Testing at one stage. Then we get to another point, we want to now test it on what? Human beings. To now check whether there are what? Side effects. It's not. You must be sure that that drug will not kill you faster than the disease that you're trying to cure. So most times we want to be what? 100% what? Sure. But can you be 100% sure? Can you be 100% sure that it will not kill you?
No.
It must be at least what? 99%. Not. But the problem you see that most times you may not even get to this stage. You may not even get to this point. You know? So that's why when we look at accuracy, sometimes you can try. The highest one you get, maybe 90, maybe 98, but the better, right? Sometimes it can be 70%. If it's 70%, you try to improve it, it can get to 71, 72. Sometimes it can get to 80, sometimes it can get to 95. So it now depends on you. So it is the model that gives you the highest accuracy score is the one you now take and you now deliberate. Is this worth deploying? So in medicine, it has to be as high as possible. That's why I remember when they were trying to come up with the vaccine for COVID, what was their success rate for it? When they were doing their test, what was their accuracy for it? Like Pfizer, what was the accuracy rate for it? What was the accuracy rate for it?
I think 98% or 97%.
95.
Was it up to?
Some was 71 around that.
71, right?
Yes.
71.
But yet, they have still deployed it. It's not, they still implemented it. So that's why you see, even when they have come and say, some will say 70, some will say 80, some will say 90, right? So all depends, but the higher the better. Okay? But you see, you keep trying and keep trying and keep trying. I'm sure by now it has improved from the first time they have done it. So that's why you keep what? Improving the model. You keep. So what they call it tuning, model tuning. They call it model tuning. You are tuning the model till it gets to what? A higher what? Accuracy. That's exactly what you still do. Okay? So what you are going to do is break the data into two parts: train data and what? Test data. So what does train data do? Train data is saying, okay, based on what I have seen now, let me apply this algorithm to try and understand the patterns. Can you see that? So training means you are trying to understand the patterns. Okay? Once you have come up with the training data, you will now come up with what? A model, is not? So it is this model that we are now going to get data for, is not? So we have built the model. So what we have done here is model building. So we have built the model. Now we have collected the data. You see that? Now we have collected the data. We'll now go and train on the data by applying what? An algorithm. Is it not? Which algorithm do you think we are going to apply in this case? Which is the most suitable algorithm we can use? Which algorithm can we use?
Binary.
We will use what? Binary what? Logistic. Why are you using binary logistic? Why are we using binary logistic?
Because we're trying to find out if they clicked on the ad or not.
Whether
yes
so it has only two possible outcomes, is it not? It has only two what possible what outcome, whether they click or no click. Can we see the process now? So it is this process I want to model. It is all this process now we want to model. Is that clear? So now we have got the data. Now, which stage are we in now? Which stage are we in now? Based on this process now, which stage are we in now?
Data.
We want to what?
Split it.
We want to split the data, is it not? We want to split the data. So how do we split the data? We have what they call, we need to do what they call, we break it into two. train and test. So we have y as a function of x. Y as a function of what? X. So what are we going to do here? We are going to break it into two, train and test. Whatever you do to your y, you must do to your x. You must also split it into two, train and test. Okay? So based on that, we'll now break it into what? X train, X what? Test. Can you see that? X train, X test. Then we have another one. What again? Y what? Train and what? Y test. Okay? But you see, before we do that, we need to first of all bring in what? Another library. Before we can split it, we need to bring in another library. Okay? And what's that library called? What's that library called? Train test split. Train test. So from sklearn dot what? Model what? Selection. What we do? We are going to import what? Train test. Okay, so once we have done that, we can now run it now. We can now run it. But that would have brought in the other libraries, but that's fine. We'll do it as we need it. So now what do we want to do? We want to what? Train. We want to test and want to what? Split. Now, X and Y, we want to train now. Now, remember we said when we are doing train and testing, what percentage are we going to use to train? And what percentage are we going to use to test?
You said 80-20, right?
So you can use 80-20, you can use 70-30, you can use 75-25. So which one should we use?
80-20.
So test size, so our test size will be what? What will be our test size? 20%, that's 0.2, isn't it?
0.2.
Then if you want to use the same random data with me, so we are going to pick the data randomly, isn't it? So random what states. So I can use any one, I can use 0, I can use 1, I can use 100, I can use anything I want to. Okay? So what have we done? We have split the data into what? X train and what? X test. We are broken again into what? Y train and what? Y test. So look at it here. So if I say Y train, can you see Y train? That's broken it down. If I check Y test, look at Y test. Can you see Y test now? Random, we picked it randomly. If you look at it again, X train. Look at it again. Can you see that? Why we have what? X what? Test. X what? Test. Can you see that we have picked the data what? Randomly. So when we are running the model, what are we going to do? We are going to use Y train on what? X train. Then when we are going to test, we are going to test what? X test, we'll compare it with what? The Y test. Can you see that? That's how we're going to do it. All right. I hope this is clear so far. Is this clear?
Yes.
Now, there's another thing we normally would do, right? Most times we need to what? Scale the data so that we'll all be in the same form. We need to scale the data. Okay? Should I do scaling or should I just run the model as it is? Should I scale? But normally, standard practice, you are expected to scale the data. Okay? So they can be of the same form. Now, if you look at that, your data, right? Do you notice that some are in thousands? Can you see some are in thousands? Some are in small figures, some are in hundreds. Do you see that? Because of that, you need to bring them in the same form. So what we do that by what? Scaling. Is that clear? So that's what we normally will scale because they are in the same form. But if all of them were all in the same distance, like 80, 100, 1, 200, they are not so far, then that is fine. But when we have some 10, some will now have 10,000, some will have 1 million. You see, they are not in the same format and the same scale. So what do we need to do? We need to what? Standardize it. Is that clear? So we need to what? Standardize. So how do we do that? We now have to bring in another library to do that for us. So from sklearn dot what now? Pre-processing. Is it pre-processing? we'll now have to import what they call standard scalar. Standard scalar. I hope this is correct. Because sometimes I don't usually remember all their syntax, okay? So if you want to do the standard scaling, what we can simply do, we can call it, we can just create an instance for it, standard scalar. Standard scalar. Okay, so we have run that now. So that's STS, it just means standard scale. So it means you have called the instance. You can just use SC. You can just call it SC. Anything you want to call it, you can just call it. Okay. So to do that, what do we do? We need to apply it, you know. Whatever you do your X train, you must go your what Y train, you know. So we can now scale, especially for our features. So for X train, we are going to scale it down. We are going to scale it. Remember, they are in different order. Remember, they are in different order. So we have to scale it. Whatever you do for your X, you must do for your X test. Okay, can you see that? We have to scale it down. So how do we scale it down? So I want to scale it down. So how do I scale it? I will scale it by what? Applying that the scalar function there. So how do we do that? By what? Fitting. Fit dot what? Transform. So what? Transform that what? Data. So what are we transforming here? We are transforming what they call X string. Say standard scalar object not fit transform. Okay, transform. Transform. How that works? Good. So if I run X string now, look at what has happened now. Do you notice anything now? What has it done? What have you noticed now? What did you notice?
Transform the data and normalize.
It has brought them now in smaller scale. Can you see that now? You know, before they were in thousands, hundreds. Now they are all in the same word scale. Can you see that now? So they have now been brought in the same scale. So whatever you do for your train, you do for your test. So I'll do the same thing for my test. So look at my test. You see how it is now. So what do I want to do? I want to what? Scale it down. So X what? Test. So I'll apply to my what? X test. So whatever you do for your train, you do for your what? Test. So let's run it now and check. So can you see we have brought them down to the same level now, is it not? So all we have done here is to scale it. Now that we have scaled it, we can now go and what? Apply the model, is it not? We can now go and what? Apply the what? Algorithm on it. So we have done train test, we have now scaled. Next we are going to do is to what? Apply the algorithm. Is it making sense so far? Don't worry about the codes. Forget about the codes because code is not really important. It's just for you to understand what is going on at the back end. So when you say you are building a machine learning model, this is what happens at the back end. Okay. Sometimes the front end you see is those ones where you see, for example, you watch Netflix. After watching a horror movie, based on that horror movie, to now recommend that horror movie for you. It's pattern. That is front end. But at the back end is a recommendation system based on pattern. This is what's happening at the back end. Okay. So which algorithm are we going to apply here? Which algorithm are we going to apply?
Sir, please, I have a question.
Yes, go ahead.
For those of us watching the horror movie,
yes,
right, will there be a session where it's like broken down to us because we are just joining?
Yeah, so you know, so one that way I'm saying each scenario can start by 12, right? For the new people by 12, so that we can go back a bit. But however, all these things are all recorded. So if you look at the YouTube videos, you will see the ones from the beginning, from Excel, Power BI, SQL, foundation of Python. Now we are machine learning.
Okay, sir.
You get
Thank
you. So that's just the thing.
A quick one.
Yes.
Please, is Power BI compatible to Mac Pro?
Not directly, no, not directly.
Okay, so I need to get
Yes.
a Microsoft, right?
But if you are if you are very good with Mac, you know you can have a virtual machine on it where you can install Windows. Then based on that Windows, you now go and install Power BI inside it.
Oh, okay.
That's a long process on its own.
That's a long story. Okay, no problem.
And
Thank you.
it costs quite a
Just-
lot. But
I'll
even
just
just
sort myself.
around.
Thank you.
So, but try and just get a Windows system.
The Windows, okay, no problem. Thank you.
All right, great. So what's next step now? We are going to apply what? A machine learning algorithm, isn't it? So what algorithm are we going to apply? What machine learning algorithm are we going to apply now? What machine learning algorithm are we going to apply?
Binary logistics, no?
Binary logistics. You know, so we're going to bring it in. So from sklearn, so sklearn is the library that we usually have all your models. So linear model. We're going to import what? Logistic regression. Please confirm I don't make any mistake in the spelling. Okay, good. Probably should we bring in the metrics? Should I bring in the metrics now? Okay, let's just run it first. Let's just run it first. So what do we want to do? We want to classify. You know, so this is a classification case, is it not? So this is a classification case. So we can just call it classifier. So we'll call it what? We want to create an instance. Logistic regression. That logistic, beautiful. So this is the instance now, classifier. So which means whatever model I want to do, this is what I'm going to be applying on it. So it's showing that it's a logistic regression I'm going to apply. All right. So how do we do that? We now want to fit the model. So we want to fit the model. So how do we do that? Classifier dot fit. How are we going to fit it? What's our model? What's our X? X train is not, and what? Which other one? Y train. Can I see that? X train and Y train. What did you tell me? No attribute validates. X train and Y train. So let's see what has happened. Okay, probably I think this is what has happened. I think when let me try it. So let me bring that in my X, my Y, train, let me test, let me bring that in, one, classifier, okay. So what's the problem here? Data frame has no attribute validate. So let me see. So logistic regression. Please check if I don't make any mistake in my spelling. X train, Y train.
When you call the instance of the classifier, there has to be two brackets after the.
Where?
When
Okay,
you call,
here, right?
No. Where you have, yes. Yes.
Here now.
Yes.
Yes. Okay. Good. Okay, great. So now we have run it, so we have applied, we have fit the model now, right? We have fit it. So you know when you fit the model, right? It's going to come up with your intercept and slope, right? So if I want to bring in the intercept in your regression, but you know, mostly for your logistic regression, what you're interested in is more like the accuracy, okay? But if you want to just see it, you can just call it, I can just bring the coefficient there. Classifier dot what? Coefficient. So you can see the features there, this thing there. But if I want to bring it out so that it just look like a normal regression, just like you have it in Excel, there's another library for that. There's another library for that. There's another library for that. But let me not bother us with the library. Let's just show, let's predict. So how do we make the predictions now? How do we make predictions now? So it is based on these features we are going to do the prediction. Based on these features, we are going to do what? The prediction. Okay? And how are we going to do that? We have what we call it Y-pred. Y means predict. You know, we want to predict it. We want to predict it. So we have what? Classifier dot what? Predict. What am I predicting? I'm using the word X test. Now, if you remember the process, right? Based on the model, we got the data. Based on the data we have trained, we are broken into to train and test. We have applied this algorithm on the trained data. Has the test data, has the model seen the test data? Has it seen the test data? Has our model, has it seen the test data?
No,
it's not. So we now want to apply this test data on our model. Okay? So that it can help us do a prediction. So that prediction is what we are going to put here. So we are going to apply it on the model. So we have predicted now. So this is your prediction now. So based on the pattern it has seen, this is your prediction. What is 1010? What is 110? 1010? What does this mean? What does this mean? 101010. What does this mean?
I think it's the target number.
That's your target. Remember, whether they clicked or they did not click. Is it not? Whether they clicked or they did not click. So it has done the prediction.
Yes.
So what we would like to do is to check. You know that we still have our Y test, is it not? You know your Y test was the actual. You know your Y test is still the actual, is it not? We have not seen it yet. But we have given it the test so that I can do what? A prediction. That's your Y prediction. So to now know whether it makes sense, we now will compare what? This predicted value with what? The actual Y value, is it not? So if it matches, that means the accuracy will be high. If it doesn't match it, then your accuracy will be low. So that's exactly what we are trying to test now. Okay? So to do that, what can we do here? What can we do now? And you know, even for example, you know, like this, we have predicted Y and Z. Do you know we can also predict the probability? You know, we can also predict the probabilities, right? So if I want to bring out the probabilities of it, so this one means this person did not click, this person clicked, this person did not click, this person clicked. But what's the probability of him clicking? Or probability of him not clicking? Okay, that is why you see probability is a very important skill you must learn. Because remember, probability is what? Likelihood of occurrence. So what's the likelihood that I'm going to click and what is the likelihood of him not clicking? So to put it in the probability form, so what do we now do? The same way, I can call it Y probability. Or Y proba. Okay? So we still apply the same thing, the same classifier. Predict, I think predict proba. I think predict proba. Okay? Then we have our what? X for test. Now, because they are not in the same discipline, now we need to first of all put it in the same order. Classifier not defined. Classifier. So my spelling classifier not. So if I run Y prob now, can you see it now? We have now converted it. So you see this one now. You see what we see is 0. It means he has a 16% chance of clicking. You see this one here? It means what? He has what? A 57% chance of clicking. I hope you understand it now. So these are now the probabilities. These now what? The probabilities. Okay? So what we can do, we can just put it in a simple table so that we can actually see what's going on. We can put it in a simple table so we can see what's going on. Okay? We can put in a simple table. So in that case, what we can do, we can just say, okay, let's say final result, or let's say we just say result. We can put in a data frame, so we can just read it. So PD dot what? Data frame. Okay. So we have maybe like the actual, right? So probably we have the actual. What's our actual data? What was our actual data? Which one is our actual data? Which was the actual data there? These are our Y test, is it not? Our Y test is our actual. Because that's what has been predicted. Then we have predicted. We have predicted. Which one was our predicted? Was our Y what? Spread. That's our predicted value. Let me rub this up so that you can see what is going on there. Okay, good. Great. Then we also have what? The probability of it. You know, so the probabilities. So probabilities. The probabilities was Y what? Prob, I think. Y prob. Enemies at work. They say data must be one dimensional. So let's check what's the problem there. Probably they are not in the same shape, right? So if I say so shape, so this is 200. Okay, I think this is where the problem is coming from. Our Y prob 200. Okay, that's where the problem is coming from. Why our prober Y prob 200 lose Y what? Which are Y pred? Okay, Y pred 200. So it is in our Y test, you know. So the problem is coming from our Y test. So what do we need to do for our Y test now? What would we do for our Y test? We need to reshape it, you know. So I need to reshape it. So I have MP. So we can use our this thing now to reshape it. So Y test dot what? Reshape. What are we reshaping it to? Let me just reshape that. Let me test it again. Y test dot shape. Aha, so I got it now. So let me run this now. See they're in the same shape. Okay, so that worked. So result. Great. So can you see that now? So this was the actual. So look at the model now. Actual data said he clicked. He predicted that he did not click. Can you see that? Actual said he will not click. The model predicted he will click. He did not click. The model predicted he did not click. Can you see that? He clicked. He actually clicked. The model predicted he clicked. Can you see that? So based on this, you want to check how accurate is this model. We want to check how accurate is it. Can we even rely on this model? Can we rely on this model? So we need to test for what? The accuracy. Okay? And how do we test for the accuracy? How do we test for the accuracy? You will need to bring something they call confusion matrix. There's something called what? Confusion matrix. This is where confusion actually comes in. Confusion matrix. Okay? So bring in what they call the confusion matrix. I'll try and explain the confusion matrix, but let me just run it so you see what you're looking at. Now look at what it's going to do here. So let me call it confusion. So that is going to confuse us. So let me just call it confusion. Or CM. What do we call it? Confusion or CM? What should we call it? Okay, let's leave it as confusion. Confusion. So we need to bring in the library for it. So what library will do our confusion matrix for us? Which library? I think it's still from sklearn. sklearn. I think there's matrix. sklearn.matrix. I need to import what? Confusion matrix. I hope this is it. Okay, that is it. So here you can just say confusion. So I'll apply the confusion matrix. So I'm applying the confusion matrix. What am I applying it on? Look at what I'm applying it on. I want to check. You see the y, the actual, our actual is what? Y test. Y our predicted is what? Y pred. You know, so I'm going to compare both of them. So I'm comparing what? Y test with what? The Y prediction. So let me run it and see. Confusion. Can you see the confusion matrix? So let me explain what this confusion matrix is doing. So let me try and explain what this confusion matrix is doing. It's just like saying, you know when you go to hospital, right? You know when you go to hospital, imagine a man going to hospital. They take blood tests for the man, right? They take blood tests for the man. And the model is telling him that he's pregnant. Is that correct? A man goes to the hospital. He does the test. And the test is telling him that he's pregnant. Is it correct? Would that be accurate?
No.
Would that be accurate?
No.
No. So let's look at it. So look at how they break it down. You have the actual values. It's not actual values. So let's use the test. Actual. Is it not? So we are looking at, so we want to go and run pregnancy test. So it's either you are pregnant or not pregnant. Can you see that? So it's either you are actually pregnant or you are not pregnant. For example, a woman can be pregnant, but a man cannot be pregnant. Is that not it? Or can a man be pregnant naturally?
No.
So this is the actual.
So you can.
He can naturally. So naturally, can a man be pregnant?
No.
Or he predicted that he's pregnant or he's not pregnant. Can you see that? So you can see that. So this is like our actual 1, 0. Can you see that? Actual. The predicted 1, 0. Do you see that? So these are our predicted values. These are our predicted values. These are our predicted values. These are what? Actual values. These are what? Actual. Actual. So let's look at it. A woman went to the hospital, right? She ran tests, and they say you are pregnant. You know, they say you are what? Pregnant. Can that be positive? Can that be possible? That she can be pregnant? Is it possible that she can be pregnant?
Yes.
Good. So anytime she can be pregnant, right? It is positive. That means she's pregnant. It's positive. Anytime she's not pregnant, it means it's what? It's negative. Can you see that? So it means it can either be what? Positive or what? Negative. Do you get that now? So when you see 1 here means actually you are pregnant. On this side actually means the model, the test predicted that you are what? Pregnant. So everything on this part here, it means it's positive. It's either you what? You predicted positive or the test came out was positive. Can you see that? Why here 0 means either actually you are not pregnant or negative, or the model predicted is also what? Not negative. Is what? Negative or not, we are not pregnant. Okay? And that situation is that you are a woman. Can you be pregnant? You are a woman. Can you be pregnant? You are a woman. Can you be pregnant? You are a woman. Can you be pregnant?
Yes.
So that is all true. You are a man. Can you be pregnant?
No.
You are a man. Can you be pregnant?
No.
So that is called a false. It's called what? A false positive. It's called what? A false positive. Now, can you see that? You are actually pregnant. You are a woman. You know, you can be pregnant. You know, you are a woman. You can be pregnant. But the test says you are not pregnant. Right? So imagine now, here at this point, you are a woman. You can be pregnant. It's not. You are pregnant. Yes, not. But the model says, the test says you are not pregnant. The model says you are what? You are not pregnant. So what is it? It is called what? A false. It's called what? A false negative. You are a man. Is it not? You are a man. The result says you are not pregnant. You are a man. You are not pregnant. That's called what? A true what? Negative. It's called what? A true what? Negative. Do we see that? Which of this is more dangerous? Which of this is most dangerous? False positive or false negative? Which is most dangerous? Which is more dangerous?
False positive.
Huh? False
False
positive.
positive.
Okay, so it now depends on the issue, right? For example, if it was actually a man that went for pregnancy tests, should we be worried that he's pregnant when the result says he's pregnant? Will he be worried?
No.
You may not be worried now in this
No.
instance because it can vary from situation to situation. For this instance, a false positive may not have significant impact. Is it not? But a false negative, which means you are pregnant, but the result told you are not pregnant. Which means you'll be living your life normal, is it not? But yet you are feeling the symptoms, is it not? This one can be more what? Dangerous in this instance. But imagine if it was COVID. Imagine it was COVID. If it was COVID now, imagine it was COVID. You ran to do your test, right? You went to go and do your test. The test says that you are what? Positive. But in actual sense, in the actual fact, you have no COVID, but the result said you are positive. So the only implication is that you'll be worried. It's not, you just be worried. But it has no real implication for you. But you just be worried, you just be anxious. You may start taking drugs, spending money on drugs. But the result says you are positive. But meanwhile, in actual fact, you are not positive. But imagine now, you actually had COVID. And the test says you don't have COVID. Which is more dangerous?
The first negative.
Negative.
Because
Yeah.
the disease is still in you, but the result says it's not there. That is why, for most models, you must subject it to this word confusion. You see how the confusion matrix comes? You see where the word confusion comes in? By itself, it looks what? Confusing. But how do we know we are correct? Where we predicted, it actually happened. And with the model predicted, it actually happened. So, true positive. It did not happen. And the model predicted it did not happen. That's true negative. So this is exactly what we are using to test your what? Model what? Accuracy. Can you see that? That's what we use to test what? The accuracy. Okay? That's what we use to test what? The accuracy. So what will be the accuracy of this model now? So how do we test the accuracy of this model? So do you think this accuracy of this model, do you think it will be high or low? This is our model based on what you are seeing here now. Do you think it will be high or low? Based on what you are seeing here, do you think it will be high or low?
It will be high.
It will be high, right?
Yes.
It will be high, okay? So let's try and run it and check. Now, if you look at the matrix, can you see read the confusion matrix now? Do you think it's high or low? Based on the confusion matrix, do you think it's high or low? Based on the confusion matrix, is it high or low?
It look high.
It looks high, is it not? So let us bring in the accuracy score. Let's try and read the accuracy score. So from sklen.matrix, import which library is that one? I think accuracy score. Okay. Let's bring the accuracy score. So let's bring accuracy score. We've checked that my spelling is correctly. I'll use y-test and what? I'm running y-test and what? Y-predict. No, remember I classified it. No, I have to predict it. So I'll use the classifier to predict. Can you see that? This is the same thing what I have done initially, right? But I just want to rerun it again to check. So what's our accuracy score here? What's our accuracy score here? What's our accuracy score here?
About 91%.
About 91%, right? You know, when I ran this one, initially I did not scale it. I didn't scale it. Because when I ran it again, I think I omitted the scaling part. So if I have gone to scale it now, if I do the scaling now, right? Let's assume I have scaled it now. So let me scale, transform. So that first one I have done, I didn't transform it. So when I run it again, I didn't transform it. So let me run them back again. So I have my classifier and the confirm that it's working, train it. Run it. Yeah, I've trained it already, right? Okay. So when they say you are fitting the model, that's the line you are running, that's what you are doing there, you are training it. So let me run that. Okay. Let me predict. Let me run this again. Over. What again? Shipping. Let me put it again so I don't forget. Let me ship it. Then let me run this again and check accuracy score. This one even reduced. This one even accuracy even reduced. Let me see. 1281. This one even reduced. So you see, you can keep trying. So you go and check now. You go and drop the variables and go and check. Keep trying till you get the best. Okay? Till you even get what? The best result. But you keep trying the model till you what? Get the best result. So whenever you are running a machine, so what we have done here, we have built what? A machine learning model. Okay? We have built what? A machine learning model. So probably what you can do is either one, we increase the data, two, we can even increase more features or drop the features. Okay? So that's it about machine learning, logistic regression. Sorry guys for the new people. I hope the horror movie was not too scary. I hope it was not too scary. I will go back and I can go back and recheck this model again. For example, we can drop another, if we think another variable was not important, we can drop the variable or bring in the new variable. Then we'll keep trying till we get to about the highest one we can use. Then if we can rely on that, then we can now go next level to deployment. You can now deploy the model. All right, I hope you have an idea of how machine learning works now, right? So this one is all at the back end. So normally when you want to deploy, you now either build it in form of what? A mobile app,
or put it on the website. Just like now you have your ChatGPT. They have done all the machine learning at the back end. But that one now uses text, what we call the large language model. Okay? But now that one works with text. That one, when you put your input there, it will now give you the output. So if you go back to the internet data there, you know, go through the pattern based on what you are seeing, you now bring out the output for you and do the prediction for you. So that's how, so this is what happens at the back end. All right, guys, I think let's end it here. I have to go and be in that session now. So probably we'll start again. We'll give another example again. We'll give another example and probably show another machine learning algorithm. We'll try maybe like 3-4 algorithms. Then based on that, we'll now pick the best and now see how it works. All right, thank you very much, guys. And enjoy.
Thank you, sir.
All right, thank you for the class.
Thank you, sir.
Thank you, sir.
We are watching horror movies. Instead of us to be watching family
Thank you, sir.
friendly movies, you know. All right, thank you. Take care.
All right, bye, sir.
All right, bye.
Thank you, sir.
Yeah, bye.